All right, we're back, and it's COMP228, and it's week 2, lesson 2, part 3. And this is our first week of the broadcast. It's hard to know who's joined and who's on. So certainly you can try and join me on Hangouts on Air, and if you want to send me a quick message, you could certainly do that. What we're going to be covering in this particular session, and again, it might be a little bit different than normal, but I'm going to make the screen as large as I can so you can see our PowerPoint presentation here. And again, we're going to try and do the stuff that's more theoretical during this session, so there's not as much interactivity. And it's going to reinforce the stuff we did this morning, right? So this morning we did a bunch of stuff with Eclipse. Let me just bring that up. So for those of you who were with me this morning, I had Eclipse going, and we did this simple example this morning. These last two videos that I kind of put up on YouTube here. With Eclipse and this program class that I run, where I run this thing and we say Tom runs this program that we kind of did with Eclipse, right? So we're going to continue this session to try and add a little bit to this from a context perspective, right? I also, one of the other thing I kind of did was, and if I bring up, let's just bring up another window, another Google window here, browser window. If I go to GitHub, right, as an example, and if I go to Centennial College, which is where I have stuff, I have the lessons here for COMP228 lesson 2. You can always follow this on GitHub, and you can certainly fork me if you want. The completed lesson so far is up there. I might add a little bit to it, but probably not a lot as we go through this particular lesson. Okay, again, first time we're broadcasting. I'd love to hear your feedback. So when we get to class the next week, or if you want to send me an email or something like that, you can certainly kind of send me your feedback and let me know what's going on. Okay, cool. So let's move on to what we're going to be covering in this particular PowerPoint. So again, we kind of covered some of this already today in class during the morning session. That was between, again, 10:30 and 12:30 this morning, right, in session one of our Java class, right? So we covered how to declare a class and use it to create an object. We covered how to implement a class behaviors as methods. We covered most of this stuff, but we need to talk about a few other minor points, which I want to get to. And again, some of this stuff will be on your next test. So when we do a little test, we're going to talk about some of this stuff, so that way, that's why the PowerPoints are there to support you, so that you have enough theoretical information you can use when you do your test. And again, we kind of worked in lesson 1. We kind of worked with, print line, printf. We kind of did a little bit of that today in our class this morning. We also showed you how to do an output with system.out. And again, by the way, if you want to follow along with me instead of watching the broadcast, or if you want to put the broadcast on the side and follow the PowerPoints at your own leisure, you can certainly go into eCentennial, where I have them right now, and kind of pull down the PowerPoint presentation as a PDF, and you can use it there. So again, we kind of talked about input and output. So input being the scanner class and how we use that, and output being this other stuff. We covered that in lesson 1. We also, when we create or instantiate different objects and classes, some of the stuff we use is we use some primitive types. Primitive types would be things like, data types like integer and float and string and so on. Those are kind of like primitive types that we use. Well, maybe not string, but the rest of them are. And when we make classes, new custom classes, what we're actually creating is a new type. So that's one thing you can look at. And a lot of times what I do is when I make these PowerPoint presentations is I have these things, they've got something that's bolded. If there's a term that's bolded, a lot of times I may test you on it. I may talk about things like what I mean by a new type. So think about when you make a class. Typically when you have a primitive type, you only have one input or output, if you will, one output, right? It only returns one thing. With a class, you could return many things in the form of an object. We'll get to that in a bit. So again, the book has several different examples using the account and the account test classes, those two classes that they use in the book. And we're going to kind of look at this, to kind of dissect the code a little bit when we look at the book's examples as we go forward. All right, let's take a look at some other stuff here. Go to the next slide. again, there are different, again, what they're talking about here is there are different accounts in this particular example that they're using in the book have different types of names. So therefore, when we go to the code example that they use, here's your public class account. And now we have a couple of things we covered very similarly in class this morning, right? We have a private variable, a string variable that is of name, it's called name, that's an instance variable. And then of course we have two, or a getter and a setter, just like we did this morning's class to cover, to kind of have, to change this private variable. Remember the convention we talked about in class. When we declare private variables for me, that's one I've asked you to do, use an underscore. And again, if I was going to go back to Eclipse for a second, here's Eclipse. Use an underscore when declaring private variables. Like for example, right now we have in our program class, there's nothing in there because remember our program class is kind of a static object, right? But in my person class, when I declare variables in my person class, I'm just going to open this up for you, just like I showed you before. I declared all my private variables with an underscore as a convention, right? Remember the other convention, the best practices are private instance variables, public properties. These public properties, or these getter and setter methods, if you will, they are what they allow us to do. These accessor methods allow us to access the variables here. And this is just, again, covering the stuff that we talked about earlier, all right? So that's the kind of stuff we got going on. Sorry about that. I'm going to get random calls here, you know, when I'm doing the broadcast, because of course, when you're at home, you have all kinds of lovely distractions, but that's just the way it is. All right, let's get back to it. So again, same kind of stuff we talked about before is what they're really talking about in the book. So if you follow the book, and again, for those people who don't have the book, it's Deedle and Deedle, you know, Java How to Program 10th edition early objects, right? Which is kind of talking, we're talking about chapter 3 here. And if you notice, it's figure 3, chapter 3. Last week we covered chapter 1 and 2 from the book. This week we're covering chapter 3. Okay, so really that's what it is. So if you look at account, each account then would have its own name. So even though we're making the blueprint for the class, each object then would have its own name property that you could change. Very, very simple and straightforward stuff. So again, when we declare our class, just like we showed on line 5 here, public class account, right? What we're doing is and again, this is very similar to what we see in C#, nothing different here. We're declaring our class. We use, again, the access modifier, whether it's public or private. Typically, our classes are public, typically, not always. We use the class keyword and, of course, the name of the class. That's what we do. It's saved as a Java file, a .java file in Eclipse. If you notice on the left-hand side here again, in our package explorer, what we have is the name of our class is in our default package. So it's .java. These two classes here are the things that we're seeing when we create our classes. And again, I've got this other person class here. Okay, very, very cool. So stuff we've covered before, just a review, right? Now again, they talk about here on this page on slide 8 that we're on right now, they really talk about naming conventions, and we've kind of covered this already when we talked variable names. We talked about upper camel case or camel case. Camel case for most variables, upper camel case for methods and class names. Okay, then the difference, of course, between an instance variable and what that is. So if we were going to define this on a test, it says an object has attributes that are implemented as instance variables. Okay, you can call them attributes, you can call them class variables, you can call them instance variables. They're all the same. So if I was going to test you and I said, you know, an object has attributes, you know, what are they called? And if I was going to give you an ABCD kind of question, what would it be? Then one of them might be instance variables. Okay, and that would be the correct answer, by the way. Okay, very, very cool. And again, a class, it says, normally contains one or more methods that manipulate the instance variables. We showed that already. Remember, we kind of did that already one time. In the beginning, we said, hey, these are accessor methods. They manipulate the variables. Those are kind of some of them. And the other way I did it as well is I also created this constructor signature for the class that allows me to enter and modify my age variable, this private age variable that's up here, right? So it's another way I can do it. I can use the constructor method to do that as well, which is what I kind of did in class this morning. Okay. Again, if you follow along with both the code and the PowerPoint, you're not going to go wrong. You're going to have both examples, and all I'm doing here is reviewing what we've already done from a clarification perspective. Okay. Again, we can have both public and private access modifiers. Hey, here's a question for some of you guys to look up, and girls. If I only had one of these, for example, if I didn't have a set access modifier and I just had the get access modifier, what am I really doing? And of course, the answer is, if you compare it to what we learned in C#, we're creating a read-only property. That's what we're doing, right? So if I only have one of these, if I don't have the setter, as an example, and I only have the getter, that means I can only read from the private instance variable. I'm just reading the value and returning it to the user. That's what I'm doing here. So this would be read only if I only had one. If I have both, then I have both a getter and a setter. Then what I'm going to have is I have the regular. I can access both. I can write to it and read from it. So read write kind of property. It's very rare, and again, I said this when we were doing our C# code, that you only have a setter, where you can only set a variable's property and not get it afterwards. So I can write to it, but that's it. It's right once, and I can't read it ever again. Doesn't make any sense. Usually we don't have that. Usually it's either a read-write or just a read. Okay, so that's the options we have here. And they talk about this being public or private, right? And like it says here, most instance variable declarations are preceded with the instance variables are private, and the access modifiers are public. Like we said, that's just as a convention. Okay. Here's an example of another one. This is my name, and actually we did the exact same thing. The only difference here is that my name variable that I'm accessing, this .name, I use the this keyword to access the variable that is part of our class. So example would be this. It would be gender then would be the instance variable that belongs to the class, yeah? And what I'm doing is I'm using the this keyword to indicate to us, the programmer or the developer, that what I really mean when I say this gender, I indicate this one, this instance variable. Because sometimes we have variable names that are similar. Like example here, this is a local variable called lowercase gender, and I'm saying assign the gender, right, that's incoming from my set gender method, accessor method, into the gender underscore gender private variable, right? And I'm doing that by indicating the this. I could take this away. I don't need to use the this keyword within this class context. I don't have to, but it's a really good practice, and it's from a clarification perspective, it's perfect. And the other thing is, when you use the this keyword, you get into the habit of using it. It works great for C#, it works great for JavaScript, it works great for lots of other languages as well, and you can, your code becomes a little bit more portable when you do that. So if I was to move this code into another language, it further clarifies what this thing is about. Okay, so again, just another example of how that is. Now it says I could take in more than one parameter. I don't have to just, remember, this is just a method, right? So I could ask for as many different parameters as I want here, and I could set as many different variables as I want with this you know, this method, this setter method, right? I don't have to just set just one property. Again, the best practice is setting one property's value. That's what I want to try and do, and that's what we do here with the setter, right? But we don't have to. We can add this. We can do this as many times or how many properties or parameters we want. Now, here's a good thing to note, right? Why even bother? Why not just? And again, I kind of asked you this earlier, but we didn't really kind of come to an answer. And I'll kind of put it in plain words right now. So why even bother with that? Why even bother with a setter at all? Why not just set the property directly? Well, the challenge is that I can set a property with, if I set an instance variable directly. Let me go back to the code. If I want to set the age variable directly, it's an integer, right? But what if I send the wrong type of data to it, right? Like let's say, for example, not the wrong data type, but the wrong range. Like let's say if I send in 200, like typically a person can't be 200 years old these days, or let's say something more extreme like 500. So it wouldn't be really reasonable. I can see that if someone said that an age can start with from let's say 0, if we're going to make age an integer, 0 being just born, so he's not quite 1, a person's not quite 1, to let's say 120, that would be probably a good range, right? And also sometimes we would what about if it's a negative value? If someone can enter a negative value, it's still an integer, so it's not going to stop me from entering that, right? If I access it directly. But the great thing is when I have a setter method, I can do input validation. So I can give the user, whoever consumes my class or who uses my class, a little bit more feedback to say, Matt, no, I need a positive variable here, not a negative one. It has to kind of comply to this 0 to 120 range, right? So I can give user feedback back to the user saying that's the way I want it. So I can do input validation. I can use getters and setters for that. That's another reason, right? I can also format them. So I put some data in, and what ends up happening is I can format it before it gets to the actual private instance variables if I'd like. That's just, I can kind of produce a middle ground for that, so I can process the input before it goes into my instance variable. So lots of control here, right? Whereas if I access them directly, no control. I just, whatever I put in there is what I put in there. Okay, so when I'm creating a class for users to consume, that's what I'm doing here, right? There's different options, and this is the best option, best practice, if you will. Okay. Okay, I mentioned this before, but I kind of will go over it again from a concept perspective. Parameters or local variables. This is a great title, and some people get confused about this. So I go back to Eclipse, and if I have my constructor, here's my person class constructor, right? This variable here that I've passed into it is a parameter of the constructor, just like, gender is a parameter of the set gender access modifier or property, if you will. This is kind of the same thing, right? Well, gender, lowercase g, not the underscore, is a local variable that belongs to this code block, right? And the same thing goes with, inside my constructor, age, without the underscore, age, lowercase a, without the underscore, belongs to this code block. So I can't access age here in my run method. If I try that, if I go something like this, so Tom runs, as an example, and is, whatever years old, right? And if I was going to add in another value, so again, it would be %d. So let's say %d, right? And let's say I want to interpolate another value in here in that placeholder. So let's say I say age just by itself, I get an error, right? Because if I hover over it, it says, there's a problem. With the create local variable age, this is one fix, that's wrong, right? I don't want to create a local variable to assign it. I create a field age, which is kind of what I have, right? But it's the field is underscore age, and then look, change to underscore age. That would fix it, right? So that's the quick fix. Let's do this. So there's my fix, so it's fixed. But again, best practices for what we want to do in class, we want to do something like this dot underscore age, right? And that's what I really want, right? Because I want to kind of say, hey, Tom runs and is blank years old, right? Blank, years old, right? So there's that example again, right? Make this a little larger for you guys to see the whole thing. And if I was to run this to test it to make sure that it runs, and if I'm pretty confident, there it is, Tom runs and is 46 years old. But I can't get to just age. This age here, doesn't exist in this context, not in this method context. But this age, which is an instance variable, does exist. We have to access it either with just the underscore age or, by best practices, with the this keyword, which indicates this context, the context of this class. So the class's age variable. That's what I'm saying here, right? Okay, got to cover that from a local variable perspective. So that's pretty good explanation of that. So again, the set name method body, again, this is something that we've kind of covered from a C# perspective whenever we see these curly braces, because Java is a C-influenced language. We know that's part of the code block. Like I said, anything between this area here, we've kind of covered slide 13 at length. I'd say ad nauseum. Here's getName, the method of a class account. Okay, so there's some examples that they're giving us now from the book. Method return type specifies the type of data returned to a method's caller. Again, we use the keyword void to indicate that there's nothing that we're going to return. As an example, let's take a look at some examples here. So here's public string getName, right? And this is returning void, right? So really the right thing to do is put void in front of here, because that's the proper way of doing it. Again, there's a couple ways we did that. If I want to make a access modifiers for my age instance variable, right? What do? I can do it two ways. I can write it by hand like I did this morning, or I can simply go to source and I can go to generate getters and setters. And there's all kinds of other lovely things you can do here too. Generate constructor using fields, generate constructors from superclass. There's all kinds of other stuff. Generate toString. That's a great little method, right? You want to generate a toString method. That's one of the most common methods that we use. And what it actually is doing is overriding the default toString method that's part of the object superclass. But anyways, let's not digress too much. What I want to try and do is do this getters and setters thing right here, right? So this is what I want to do. And if I was to do that, it takes me to the dialog. I'm going to do this a little slower now because I have a chance to do that. And if you notice, I can do the age, and now it says get age. That's what it's going to be called, right? And set age, right? That's my default setting of getters and setters. And it says, hey, allow setters for final fields. I don't want to do that. I could also make them, instead of my access modifier, could also be protected, which means that only classes, and I remember from an inheritance perspective, we've learned this before, only classes that inherit from this class can have access to my getters and setters. Now, that doesn't make any sense in this context, but we could limit it that way. So we can use this dialog box to create, to kind of create our getters and setters. Also note that I can create more getters and setters for my gender and my name. I can do it one time to create getters and setters from anything as any instance variable that I have, that I've selected, I have in my class. For now, I would, in this particular case, I would only create them for my age variable. Now, it doesn't make any sense in this case because I have a write-only, not a read-only, a write-only method, and I'm using the constructor method to get it. So all I would need in this particular case is the read-only access modifier here to read age. So I would need a getAge method. Now there's two ways to do that. I could write it by hand, or I could use the automatic generator. Let's use the generator again. So I'm going to go source. I only want to generate the getter but not the setter this time. And I want to generate my getters and setters. And I want to choose only the getter, not the setter, because I'm setting it in the constructor method. Here it is, right here. And it tells me, well, where do I want to put this? Well, if I put it aside so I can see, I want to put it after the age, right? And it also gives me other options. After set name, get name, that's pretty good. After probably set name would be good, right? That's a great place to put it. And before the person constructor method, right? So after this, that's a great place to put it. So I actually positioned it nicely, right? Okay, cool. And that's us press OK. Let's see what happens, right? And there it is. There's my getter, right? My get age. I didn't have that before, right? So I'm going to modify this just like to match up with my style of getters and setters and put the this keyword here, my this.age, to make sure that we know what's happening, right? So now, remember we were trying to do this in class this morning, and I couldn't do that. I can't say, hey, let's see what my my age is going to be. Let's print that out here. When I do a run, I can definitely do this. I can say this.age and this.name, but what's a better method to do that? Can't I use my getters and setters instead of accessing these values directly? And the answer is yes, I could. How do I do that? Well, these are return values. These actually have, the getters actually have return values. This means this method actually returns a value. So I could do something like this. So let's replace these, this age and this name by the getter and setter. So I can say get right? So I'm saying Tom runs, so get name, say the get name value, right? And I can also say get age, because that is, I can replace those in there, right? Because that's there too. Now to make it so that it is explicit, what I'm trying to do here, right? I know that it's this dot get name, right? And this dot get age, because those two methods belong to the class. And if I use the same convention, I want to use the this keyword to indicate that these two methods are class methods that belong to my class. Now this should generate the same output as an example as I had before. Let's check this out. So I'm going to kind of run this thing. And there we go. Tom runs and is 46 years old. It's getting it there. And if I want to, right, I can access it outside of the class by doing a system.out.println, right? And I could do something like person.getAge, because that's now a getter, a read-only method, right? To get the age of the person, right? So this, I want to print this out, but I want to make it with some context. So maybe I want to print out, printf, maybe do it a little different than this. So a little bit of brackets here, and maybe some kind of interpolation with a string. That's my string placeholder. So, so like I say, again, name of the person. Again, I can do it out here instead of just in the runs method, right? So let's modify the runs method, because that doesn't make any sense, right, to do it in there. Yeah, let's save. I can do it in the runs method. So in the runs method itself, right, so here's the runs method, right? I don't have to indicate the age, because it doesn't make any sense if he runs that I would say he's 46 years old. So let's go. Tom runs, right? I don't need this get age for a second, but I could have used it before. I was just putting that in there for as an example. This is a great thing. I could say, just as an extra little bit of comment, and say, read only method or access modifier for age. Right, that's what that is. Right, that's what this read only one, because we only have a getter, but we don't have a setter. All right. So this, again, Tom runs. That's what this is going to do. And of course, in the program, here's the program piece, right? Now what I want to do is I want to say the name of the person, right? So person dot get name. There's get name. And then, so Tom is sent D, because it's going to return a number, %D, get age. Now, again, there's no validation here, but if I was going to go check this, get age is returning an integer. See, that works nicely. So if I run it now, Tom runs. Oh, hey, and Tom is 46. Well, you know what? This is great. But if I go back here to person.java, my class, maybe what I want to do is after my my printf is done, I want to put some kind of \n escape character in order for me to do that, right? Because if I don't do a \n, it won't return to the next line. Let's try this out now and see what the difference is. So that's better. So Tom, the first name that I'm outputting here is Tom, right? So that's I'm printing out Tom, right? And then the next one is Tom runs. So it says Tom runs. That's what's happening here. Person runs. And then the last one is, hey, Tom is whatever old, right? Is 46 years old. There we go. This is a great example right there for you. So that kind of uses both things. So there's your read-only method and the same kind of getter and setter that I used earlier. Okay, so I'm using the setter right there. But this right here, this isn't a setter. This is a constructor. So I'm using the constructor method to set. I'm using set name to set the name. And I haven't really touched gender at all. That's kind of unused. I could do something like this if I want. Not using it then. Person dot, set gender. Then I could assign the gender. Not gender assignment, mind you, but just gender. I'll put male, right? I could do that. Indicate that that's, so I can set my properties like this, right? And this is the way we can do it. So I can use set name and set gender, these two setters, and I'm using a couple of getters to kind of print stuff out. I'm not really showing right now what my gender is with the getter, but it doesn't matter. I have an option when the class gives me the ability or enables me to use those two things, and it protects us. So again, so more around that, exactly what we did before. Now, just to keep at pace with what we've been doing before, what I'm going to be doing here is I'm going to use my GitHub. I'm going to create a commit GitHub because I modified my thing. I added a getter method, getter accessor method to this, or age, to the age instance variable. That's what I'm doing. And what have I modified? I've modified both the person class and the program, the main program class, right? That's good. I'm going to commit and push, right? And just to check that that's done, it looks like it's okay. Just to check that that's okay, I'm going to go back into Chrome. Right, here we are in Chrome. I'm refresh, and you can see that now I added get accessor method to the age instance variables there, and I also show that I have 5 commits. Just going back to the GitHub thing, you can see that I've done a bunch of stuff here. One, look at this, 8 hours ago is when we started this whole thing, and then now 19 seconds ago, right? So it's kind of a little cool thing. That's why I really want you guys to learn Git and GitHub. It's really kind of a good thing to learn. Okay, cool. So that really covers this, again, in much more detail than what we did earlier today. Let's go to the next one. So again, we want to use this to call, you know, this account in an app and call each of its methods. Well, how do we do that, right? My method right now, the only method that I have in my current person class is just the runs method, which is kind of a silly method. But the account class, let's go back to that account class example when we first saw it. Right now, it only has getters and setters. These are the getters and setters method. That's all the account class has up to now, right? So what are they going to add now to make it more interesting, right? So got names. Let's take a look. Just going to go back here and make sure we have the right thing. So again, to help you prepare for larger programs, it says you'll encounter later in this book, and in industry, we use a separate class account test containing a method main to test class account, which is kind of what we've done. We've got almost like a program class. That's what we're using, and we're using this to drive. That's what our main class is called, a driver class, to drive the account, or in my case, our case, a person class. That's what we're using it to do. So when I say a driver class, this driver class, what I really mean is, again, account test, testing the account class, is like how we've got this whole program, right? So I got 2 classes here. I got the program class, and I've got the person class. And really my program class, remember I talked about it being almost like an index.html, or this central class where every other class kind of links into. We call this, the proper term for it is the driver class, if you will, or the main class. And the main method here, right, main, public static void main, is our main method that we link into, that we kind of run everything else from. Okay, let's take a look at that. So here's some examples of account test with a public static void main, almost exactly like we did before. One thing that they have a little different than what we had before in our class is we import the Java util scanner class, or sets of classes here, so that they can listen for an input, right? So instead of it being hard-coded the way we have it, they can listen for a scanner input. So input then is equal to a new scanner, and what they're doing is they're listening for this input. This input comes into whatever we get from the keyboard, comes into and settles into the input variable, and then the input variable is what we use, right, to determine. And again, what are we asking here? We're asking for my initial name is my account.getName, whatever the get name, whatever it's set to, and then I'm going to please enter the name. Well, I've already got that, right? I've set up my input variable, and here I'm reading from the input device right here. I'm reading a line of text, and then I'm setting the name as whatever I put in. Okay, so that's using the scanner. So I'm using both input and output to show what I'm printing out. If you go to the next one, the next slide, slide number 19, you can see that this is what's happening. I'm kind of saying I'm formatting a text. I'm saying name and object my account is, and whatever I'm outputting. Okay, myaccount.getName. Myaccount.getName is the getter method that I'm using to input to the these placeholder values here between the %ends. %ends is indicating that it's a new line, and of course it's printing out whatever I'm inputting. All right, so we can implement that for our class too. We kind of did that last week. We can kind of do it this week again. So I need to put this scanner input into our driver class. So let's go into our driver class, which is the program class for us. It's just the formal name for it. We have this system.out.println, and if you notice, my person is a new person that's 46 years old, right? So wouldn't it be nice if we say, please enter your age, please enter your name, please enter your gender, as an example. Gather that information first, and then do all the printing out. That would be the nice thing to do. In order for us to do that, of course, here, we're just going to create a new scanner, right? And the scanner, we're going to make it called input, right? And the input, of course, is going to be what? If you notice from the PowerPoint presentation, it's pretty simple. We're instantiating the new scanner. It's just an input type, right? And we're passing into it. It needs to be the scanner signature, the constructor signature requires something in there. Let's see what the options are, just like we did last week. Again, the input is a new scanner, and oh, it's not coming up. Well, if you remember what happened last week, and we kind of showed this earlier, is if I kind of hover over this option, it says import the scanner Java utility class. We kind of knows, right? And we kind of did this last week. Let's just do that. So now, of course, I got this input Java util scanner. This is cool. Now it's giving me an error here because it's saying, hey, there is a couple of different signatures for this scanner class. One is some kind of input stream, a path from a file, let's say, something that's a readable, and so on. Let's look at that again. The other one is a string, so I can actually input some, a string, a default string value. Well, I want to do some kind of input stream, and of course I know what that is, right? So system.in, right? There we go. So I'm waiting for that. So I've kind of declared my variable. Now I've declared my object, but I haven't used it yet. Again, we're just reviewing some of the stuff we did last week as well, right? So now what I want to do is I want to listen for it. I want to say something like that. I want to say system, .out.print, right? Without the print line. Please enter, or maybe just instead of please all the time, enter your age, right? Give it a little bit of space. And then what we want to say is my age then, whatever my age is going to be, take a look at what we're doing here. I'm listening for something else, a string. Now I'm declaring it inline, which is, I guess, kind of okay. Not the best use of it. So in this particular case, my age is an integer, right? So I'm going to say something like this: int, my age, right, is equal to input dot, and then next int, right? Next int. Okay, so that's what's going to do is it's going to take that information and enter from my next integer, just like it does here for next line. I'm adding in, specifically requesting an integer. Now, if I don't get an integer, I'm going to get an issue. It's going to come back with an exception, right? It's going to come back with a problem because I'm listening for an integer, nothing else, right? Okay, cool. Now, when I get this, my age, instead of passing in 46, I want to pass in my age, right? So that's what I'm going to get in here, okay? And I'm going to save this thing. Let's see what happens now, just with these little changes. I'm going to run it. Okay, it says enter your age. My age is, let's say, 40. Now, check. Now they're different ages. It says Tom runs. Tom. That's kind of weird. That's showing me to print out who I am, right? Person that's that name Tom, and then it's get name. I don't want that. Doesn't make any sense. Let's just get rid of that. Right? We don't need that part. So again, but my age, this piece worked. So this is my input. So again, I would put in some kind of comment to say prompt user for age, right? That's what this does. And let's do the same thing as an example, right? But we're going to do the same thing for the other ones. But this time we're not going to use the constructor because we don't have those kind of parameters available to us in the constructor. What we can do is we can use the setter methods of name and gender to do that. So I'm going to say, please enter your, name. It's kind of weird. I'm asking for age first, but that's okay. Leave it as is. I can probably reorganize this a little bit. I'm asking for age first because what I'm doing is I'm instantiating a new person right here, right? And that's why I'm kind of gathering this information in these variables, right? And I'm kind of declaring the variables first, right? But anyways, I don't have to do it this way. So we'll reorganize things in a second. So I'll say my name. And my name will be of type string. So there we go. Okay, so here's string. And I can't ask for a next input, right? Or next integer. I've got to go next. Can I go string? No. How about next line, right? So next line. There we go, because that's the next line. It'll kind of get the next line of input. That's a string input. So I'll get that in there. And then, of course, it'll be my name, right? So now, instead of set name Tom, I can go set name my name, right? Because that'll work, because I've kind of entered that in there, right? And the same thing goes with the same thing for gender, right? So I'll get this driver to work for us a little bit, right? Let's just fix this up, right? There we go. And then my gender the same way. Be a next line because that's also cool. Please enter your gender. Now, I think probably the right way to do it is age, name, gender, and then age. So we can kind of just move these around a little bit. So I'm just going to kind of cut and paste. There we go. Let's just fix that up. So that's got the right set of kind of input that I'm asking for. There it is. Prompt user for age, name, and oops, change the comments here to gender. Okay, cool. That should work. So again, input next line, and going to go into gender, and then of course gender would be here, right? So my gender, can't forget that part, right? Then I do a person's runs, right? And I can do a get name and get age, and I can probably use the gender too. So Tom is this many years old and is male and is so %S, whatever he is, right? Or who may not be Tom anymore, it might be somebody else, right? Because I'm making it so it's more generic. So then, of course, I would say something this, person dot get gender. There we go. And it's going to cut off here a little bit. So let's just kind of expand this a little bit more so you can see it all. There we go. Oops, I don't need 2 semicolons. All right, so again, I've got this little driver class that I've got going on. I'll pull this down a little bit so you guys can see more of it. And again, I'm going to update GitHub in a second. So save everything, run, and now let's see what I get. I get the following on my console. I get, hey, enter your name. So my name is Tom. Cool. Enter your gender. Well, my gender is male. Okay. Enter your age. Okay. Well, my age is 40. See, it comes in green. And then, of course, it says Tom runs. Tom is 40 years old and is male. Cool. I'm good with that. That looks pretty good. If I was 40, it'd even be happier days. All right. So, so again, this is a good example of using the scanner and a bit of a review from last week. Let's update GitHub for ourselves for now. So I'm going to go here to team, commit, and I'm going to say added input capabilities to program class, the program class. And that's what I've done, really. So I don't have to enter hard-coded values, right? Press commit push. There we go. So that's committed up there, right? Let's take a look at GitHub. And again, I think I've killed it. So let's bring that up again, right? And refresh. And now you can see that I added input capabilities to the program class. So I've done that 11 seconds ago. And now I have 6 commits. Again, it's a great example of some good workflow here that I'm doing, basic workflow that I'm doing here for Java using GitHub. And I'm using Eclipse, the Eclipse GitHub stuff that's built in. Okay, so that's pretty cool. All right. We'll do a little bit more, and then we'll take a short break around, let's say, 8 o'clock. And we'll continue moving and grooving until about 9. Okay, we'll take about a 10-minute break. Gives us all a chance to get some water and all that kind of stuff. Of course, you can always, the great thing about this is you can always watch this video later on, right? So again, we're broadcasting live, but it's a good chance to ask some questions or text me if you have anything. And again, my number, well, I wonder if I did share my number online. I may have not, but you can always text me if you want some information, or even send me an email. Sending email is great too, and I can try and answer your email in your breaks. Okay. So let's take a look at the PowerPoint again. So again, I did this, right? So we've got the scanner piece in there as well, and I'm entering the same idea. So even though we're not doing an account class, instead of having an account test, we use a program, a main program to do that. And again, our output looks very similar to what we see here. Okay. Moving on to slide 20. And again, we use our object for receiving input from the user, and then we use our print. We can use the next line or next, but this just reads strings. We actually read in some integers as well, and that's what we do. We use the new keyword, of course, to to create a new object. That's just, you know, basic stuff back from C#, so that's nothing new, right? And we actually use the new operator, like it says here, to initialize an object's instance variables at the time the object is created. We can do that, and of course, our instance variables, if we go back, right, in our instance variables, we don't have in our person.java, our instance variables don't have any initialization. We could initialize these with defaults. How do we do that, right? Well, right now, when we instantiate our person object, uses a constructor that takes in an age value. That's what we're looking for, and I set the age, right? But what about our, so I'm actually initializing there. What about our gender and name, right? Well, we don't really have anything. So right now, as a default, there is no value, and to be safe, we can make it so that it's null, right? So null, or the empty value for strings, is something like this. This dot underscore name. That's the actual name. We're actually modifying the value right here in the constructor. But hold on, wait a minute. This isn't efficient. We already have a getter and setter. Like we said, we don't want to directly access anything. That doesn't make any sense. So let's modify this as well to use the getter and setter. So what we're going to say is, for the name, we're going to say this dot set name. Even here in the constructor, we're going to use the set name variable because it's been declared above, right? We're going to set name access modifier, and we're going to just use the empty string. We're going to send the empty string in there, right? And we're going to do the same thing for gender. This dot set gender to nothing, right? We don't know what it is. Actually, we could set in something like a value like set name unknown, right? Unknown. I can spell. How about that? Unknown, not uknown. Unknown. Right? We don't know what the name or the gender is. By as a default, it's unknown, right? And the age is also unknown. But we're getting it right when we construct. We need to know the age. It's like we're forcing people to, when you construct your this or create this object, we're forcing you to enter the age, or else you can't, construct this thing. But this is wrong too, right? We don't have to do it this way. We could certainly do this. This dot set age. Well, hold on, there is no setter for the age, right? Because we didn't have a setter. We have a getter only because it's a read-only property. So we're going to have to do it that way. And again, like we said earlier, this is kind of more dangerous, but not really. I mean, in this particular case, we have a very simple class, but typically you want to do it like this. Even in the constructor, we want to try and use the getters and setters in here. We don't have to, but it's really good practice to kind of show what we're doing here, because we don't have to use the this underscore ever, only for these variable names here, right? And only for the internal workings of these public methods, right? Okay. So this is kind of a modified version of our class. Again, doing the same kind of thing we did before. I'm just going to save everything here, right? We're going to update later. So I do then initialize everything. My constructor now initializes all my objects instance variables, which makes it a little safer. Now, if I run this thing, I still have a lot of chance for error because I'm not really validating input too much. Let's try this out. So I'm going to run this thing. Get my name. So, Tom. And my gender. Right? I can put whatever I want, like X, anything. It's not really validating anything. And my age, -1, right? and it says Tom runs. This is Tom is -1 years old and is X, right? So it doesn't really validate anything. I put whatever input I want, right? Let's take it one step further. Let's just really make it fail here, right? So what if I try and say, well, Tom is a number, right? That doesn't make any sense. Gender is something else, mixed something, right? It's not stopping me from putting whatever I want. And my age is also some kind of really weird string. And if I press enter now, man, it fails, right? It gives me an exception that basically says, hey, hold on. I'm asking for an integer, and you're giving me a string. That's an error, right? And it crashes the program. Okay, so this is a good example of a program crash, right? And of course, we'd use exception handling typically to check to see what I'm entering here. So do some user validation, which is what I really want to try and do. Okay, so really, really positive stuff. And 1 second while I pause. Okay, and we're back. 1 second here. My little one is calling me now that he knows that I'm home. He's you know, he's going, Daddy, Daddy, where are you? But anyways, I digress. Let's continue. So as we're going through here, sorry, it's making me giggle a little bit. As we're going through here, we don't have any input validation whatsoever, and that's one thing we're going to handle later on in the course. We're going to talk about input validation, or exception handling, if you will, for you know, for Java, which is a very important you know, topic. Okay, so again, here they're giving you an example in the book, calling class account names get name method. I think we've covered this ad nauseum here. And the same thing goes with null, the idea of null. How do we say this? So local variables are not automatically initialized, like it says. And every instance variable has this default initial value, and a value that's given. And if we don't give an you know, kind of a default value, then the string is null, which is kind of a really weird value, an uninitialized value, if you will, right? So to me, I think something that you got to think about is, do you want to manually initialize everything? And I think it's a good practice to do that, to initialize everything. That's one thing you could think about doing. And the other thing is to leave it and test to see if a variable is null. Don't recommend it. I think it's always better to initialize from the get-go. And what that does for you is it gives you another level of control when you initialize. Now, there's something we could do a little different. If we go back to our Eclipse here for a second. I know I said I wasn't supposed to do all these demos, but again, it's not much different than what we had before. We kind of set up our base class earlier, so forgive me if I'm doing a little bit more. Woohoo, more programming. Let's take a look at this and see what this looks like, right? So if I want to access my this set name, setter and getter and all this stuff, I want to create this in some kind of initializer method, I could create one. I mean, it's kind of weird that I would do that, but hey, why not, right, kind of thing. So I could initialize this before I use my getters and setters, kind of thing. Right? So how do I do that? Well, one thing I can do is I can say, this is definitely going to be a private method, right? Because it doesn't make any sense that I would run it as a public method, and it definitely wouldn't be as a getter or setter property, right? It would be a method. So these are my public methods. Let's make a section for my private methods. So we're going to private methods here. Private methods. Okay, we're going to make this kind of section this thing off here like this, right? And then in here, we're going to say private, right? Void. We're not going to return anything, right? All we're going to do is modify stuff. Private void. And we're going to call this method initialize. Right? Initialize. We don't have an initialize method, thank God. Otherwise, it would be an override, right? So if you notice, if I hover over this, it says, hey, the method initialized from the type person is never used locally. Now, remember what we said as a default for methods, I like to make them an underscore as well. So I'm going to kind of make this an underscore initialize method because it's a private method. Private methods, private instance variables, we use an underscore as a best practice, right? So, okay, that's cool. I haven't done anything with it yet. Well, I want to do all this, right? Can I? Of course. How do I pass in then my age? Because age here in my constructor is a local variable. Well, I'm going to have to, of course, pass in a number. So I'm going to say int age. Again, another local variable in this. I'm passing it through. I'm actually passing the baton is what I like to say, right? I'm passing it from here to there. I mean, you might say this is bad practice, but this is just an example to get you to understand how do I create an initialize method. And I can say something like this dot underscore initialize, right? And I'm going to pass in there then the age variable, which I can just leave it just as is, age, right? And then I can get rid of all this, copy it, cut it, and I can encapsulate it inside of, or hide it inside this private method called initialize, right? Not bad practice. Actually, it's a very good practice. So what I'm doing here is I'm hiding it, I'm initializing, and it's actually very human readable now. I'm initializing not just age, but everything else, right? It would be nice if I did, instead of saying initialize age, I might want to say initialize age, name, and gender, right, with the other stuff. So instead of saying set name unknown, unknown, these different things here, I could say something like this. I could say not only age, but also a string, right, for gender and name, right? So here's name, string, right, and gender. I could do that. And now, of course, this doesn't make any sense anymore over here. I've got to change my method signature that I'm calling from here. So I'm going to say, you know, unknown. I could say something like this: unknown, known. Oops, unknown, unknown. And I could also go comma delimited. Remember, unknown, right? So unknown, unknown. I'm passing those in here, and now I don't have to do this anymore. I can just simply put name, local variable name, and gender. Now this is a long-winded example, but I mean you get what I'm trying to do here. I'm trying to create this initializer. That's a really good way of doing things, right? Because what it does is it compartmentalizes it, and from a consumption perspective, I can see what's going on here. I'm initializing my age as age that I'm getting from my constructor, and then I'm kind of putting some unknown values, right, instead of some basic. And I can actually put in there like John Doe, right, from my name. So that's the first one, John Doe, right, John, right? If I don't enter anything in, well, guess what? My name is John Doe. And my gender, guess what? It's male as a default. I don't want to say that, so I'm going to put unknowns. And then let's see if we run this thing and if it works. Okay, so here's my name. Let's see if it all works. My name is Tom. My gender is male. And my age is 46, which is the right number. Okay, so there it is. Tom runs, 46 years old, and is male. So this all works now, and I've created this class with my new initializer method. Hey, this is something interesting. Here's my constructor, right? But yet I'm calling a method that's down here. What's going on? Well, if I was doing it in JavaScript, right, what it would be called is, this would be taken care of by something called hoisting, right? Would actually, JavaScript would read this thing and then take all the methods, put them in order of being called, and they would hoist them to the top, if you will, in an order. Sometimes that causes problems. But here in Java, what it does is the Java compiler passes through this twice, passes through it once, takes a look at it, and then notices that I'm calling this method initialize before I've actually defined it, and then repositions this method before my constructor after it's been compiled. That's what it kind of does. Right, and the second pass it does everything over again, right? And again, back in the day when we were programming in C, the original C language, we didn't have that capability. So you had to write things, all your methods or functions in order, or else you couldn't access. This would give you a syntax error in C, right? So you're like, hold on a second, I'm initializing something down here, but I'm calling it before I'm initializing it. And that would give you a problem, but not so in Java. So that kind of works okay. All right, so let me just update that on GitHub. So I'm going to go to team, I'll go commit, and I'll say added initialize method to person class. Right, that's what I did, and I'm only updating my person.java class. I'm going to commit and push. I know that's been working, so I'm not going to check GitHub. And we're going to take a brief break. We're kind of 23 out of 51, almost halfway through the presentation, which is kind of a good pace. And we're sitting here at 8 o'clock now. And again, my plan is probably going to run until at least 8:45 or 9 o'clock. Let's take 10 minutes and take a brief break, and I'll be back again around 8:10 in that range and start broadcasting again. Okay?